This is R.D. Sharma solution class 12 chapter 19. Exercise is 19.25 indefinite integrals we are talking about. Now in this exercise we have to follow a formula or the result of two functions which are together to be integrated. That means you have two functions, let's call it u and v. So when we integrate these two functions which are actually a product of two functions, then the formula will be something like this. U first outside, then we integrate the second function, whichever you take. You can take x as first function, cos x as second function, and vice versa. Then you subtract with an integration, but inside this integration there will be a multiplication of two things. First, the differentiation of the first function and the integration of the second function. Please remember, the first part which you see, integration of v dx, will also be seen in the second part, but it will be multiplied with du by dx, and whatever is the result, that will be integrated. I hope you got the idea. If you're not able to understand this, then I will clearly explain it while doing this question. So u and v, u integration of v dx minus integration of du by dx multiplied by integration of v dx and integration of this whole. So this is x cos x dx, x is u, cos x is v. So first thing we'll do is, we'll take this u which is x, integration of v dx. What is v? Cos x. Cos x dx integration will do. Minus, now integration, and this is du by dx. What is du by dx? It's d by dx of x, the first function. Then the integration of v dx, as I told you, this clearly on this same thing will come here. So integration of cos x dx, which is in the first term, will come entirely like this. And these two will be multiplied. That is, the differentiation of x and integration of cos x will be multiplied. And then the final result will be integrated. So x, what is integration of cos x? It's sin x. It's quite simple. Integration remains like this. First we'll do the internal thing. D by dx of x will be 1. And integration of cos x will be what? Same thing which we have done earlier also. It's sin x. So these integration of v dx and integration of v dx will come two times. So d by dx of x is 1, integration of cos x is sin x. So sin x dx integration we have to do. Now what is the integration of sin x? It will be minus cos x. So minus minus will become plus. X sin x remains like this. Integration of sin x has become cos x, because plus has become negative, has become plus. So this is the final answer. And this formula is very important. Now how to go about it? What are you going to write actually? Like taking x as the first function, cos x as the second function. All these need to be written. Now we are doing an exercise where we are dealing with two functions, but here there is only one function. So your question will arise, how are we going to solve this? We don't have any other function. There is just one function, log x plus 1. And these type of questions, many of these type of questions will arrive, and you have to tackle them accordingly. See, 2 into 1 is 2. 2 divided by 1 is 2. That is, 1 is already multiplied with every number, every term. So you can assume that there is a 1 here. So we are assuming that there is a 1. So we are dealing with 1 into log x plus 1. So one of the function will be a constant term which is 1. Now which of these you are going to take u and which one you are going to take it as v? Okay, if you take u as 1, integration of log x plus 1 will be the second thing you have to do. But I will not go forward. Why? Because I am stuck here only. If you take u as the first function and integration of log x plus 1 as the second function, that is a log x plus 1 as the second function, you will be stuck here. And when you are being stuck, you are again falling back to the trap of the initial question, integration of log x plus 1. How to do that? In order to solve that, that's why we introduced this one. So this means that taking u as 1 and v as log x plus 1 will not solve our purpose. So we have to take u as log x plus 1 and v as 1. That is, the first function has to be taken as log x plus 1 and the second function has to be regarded as 1. Okay. Now let's use the formula. I'll write the formula now and then whenever it is required to brush up things and to feed that formula into your mind. So to start with this, we are taking the first function as, that is the log x plus 1 as u. So this has to be taken outside, log x plus 1. Then the integration of the second function, which is the second function, which is 1 dx, minus integration of Now first we have to do the differentiation of the first function. So d by dx of log x plus 1 has to be done. So d by dx of log x plus 1 is your first thing. And then the integration of the second function, that is the integration of 1. So 1 dx. And then we have a dx here. So what is the integration of 1 dx? It will be x. So let's write x into log x plus 1. X log x plus 1 was treated as a constant. So it was kept outside. In the second function, log x plus 1 has to be differentiated. What is the differentiation of log x plus 1? 1 by x plus 1. Then the differentiation of x plus 1 will be only 1. So it doesn't matter. 1 by x plus 1 will come. And how about integration of 1 dx? 1 dx will come what? It's x only. So x by x plus 1 has come. So we have to integrate x by x plus 1 dx. Let's call it as I1. So we will be doing this I1 separately and then we'll fit it into the result. So x plus 1 divided by x plus 1, you can write it as x plus 1 minus 1. X as x plus 1 minus 1. Now you can separate them out. X plus 1 divided by x plus 1 minus 1 by x plus 1. So this dx. So x plus 1 by x plus 1 dx will give you only dx, which is integration is x. 1 by x plus 1 is simply log modulus of x plus 1. Please remember, don't forget to write the x plus 1 inside the modulus, because we cannot have a negative value with log. So let's write it in the answer. X log x plus 1 remains like this, and I1 has become, because negative sign is there, so we are changing the sign and then writing x plus log modulus of x plus 1 plus constant of integration. So this is your final result. So this is the way we are going to solve that. You have to mention log x plus 1 was taken as the first function and 1 as the second function. You have to mention it. Other things I have explained you already. Now we have x cube and log x. So what is the first function and what is the second function? That plays a very important role in choosing, because that will decide the solution. So we will take the u as the x cube, v as log x. So x cube log x integration. Now when you take this u as x cube and v as log x, we are stuck here because integration of log x, again we have to do something else. So there is a wrong assumption. We have to take u as log x, that is log x as the first function, and x cube as the second function. Let me write the formula again. Integration of u v dx will be equal to u is the first function, v is the second function, u integration of v dx, and this whole v dx will come again. So minus integration of first differentiation of the first function, that is d by dx of x cube has to be done. That is d by dx of u, and integration of v dx, and then we have to take this as dx. Now let me tell you, u is taken as log x, v as taken x cube, so d by dx of u has to be done, log x has to be done. So let's take this. Now u is log x, we are taking it outside. Integration of v dx, which is x cube dx, minus integration of what is d by dx of u, which is d by dx of log x. Now this is very easy. Integration of log x needs some effort. D by dx, differentiation of log x is very simple. Then integration of x cube dx, and we end it, and this dx. So this x cube by x cube will be x raised 4 by 4. This will be the integration. So log x to the power 4 log x by 4, because x cube was x to the power 4 by 4. And d by dx of log x will be 1 by x, and x cube integration will be x to the power 4 divided by 4. So x gets cancelled, you'll get x cube by 4. And this has to be integrated. See, one integration gave us x to the power 4 by 4. But d by dx of log x has given 1 by x. When we combine them, we got x cube by 4. So x cubed integration will be x 4 by 4. 4 is already there. That is why it has become x to the power 4 by 16. So this is your final result. The formula is very important. If you learn it by heart, all the other questions will be quite easy for you. So this is your final result. You have to follow this. Now there are certain questions of e raise x, and this will be coming later also. You'll see the next question and next to next question, they will have this e raise x. So most of the time what we do, if you learn this question, you will know e to the power x has to be taken as the first function or the second function. Now let me write the direct result. First x we have taken as u, integration of ex dx, then the integration of first d by dx of x, and then the integration of e raise x dx. So let's do this. Integration of e raise x dx will come again here. So integration of e raise x dx will do. And then we close this, and this is all integrated. There is a brace sign or the curly bracket initial I have put in, that is wrong. I'll just try and imagine that it is an integration sign. Integration of Ex will be what? It will be Ex only. So x e raise x and d by dx of x is 1. 1 into e raise x will be e raise x. So e raise x you can take common, x minus 1 will remain inside plus constant of integration, and that's your final result. So this is how it has to be done. Always take most of the time e raise x as the second function. That's how it will go about. Now you see the next question. This is almost similar, and the next question we are going to do, this is also so similar. E raise 2x has to be normally, I'm not saying all the time, but most of the time e raise 2x is to be taken as the second function. So first function x, integration of e raise 2x dx minus integration of d by dx of the first function which is x, and then the integration of the second function which is integration of e raise 2x. That has to be done twice because the first term also contains that, and then all this has to be multiplied and then result has to be integrated. So this will be d by dx. See, first term we can write e raise 2x will be e raise 2x divided by 2 because differentiation of 2x will give you 2, that has to be divided, minus d by dx of x is 1, e raise 2x will be e raise 2x by 2. This integration will be 1 only, so e raise 2x by 2 has to be integrated. What will be the integration? 1 by 2 can be taken outside. E raise 2x will be again e raise 2x by 2. So e raise 2x by 2, and there is already 2 in the denominator, e raise 2x by 4. So e raise 2x by 4 plus constant of integration. That's your final result. Let's make it more easier. If you take 4 common from the denominator and e raise 2x from the numerator, what are you going to get? So have you taken e raise 2x outside? So it will be 2x inside, and since this already has been taken, it's only 1 will remain inside plus constant of integration. There is some other way also you can go about it. I'll show you the result. So this is the way, this is a different type of solution which you see here. Means the result, the solution remains the same, the result may vary. Again a question with e raise negative x or e raise x, the same technique or the approach has to be followed. So e raise minus x, normally we take it as the second function. So u as x square, v as the second one. Now when we integrated x square, integration of e raise minus x will do, minus integration of d by dx of x square has to be done. This is the first function. Then the integration of the second function which is already there, integration of e raise minus x dx will do, and these two are separate functions, a result which will be multiplied and then whole will be integrated. So e raise minus x will be e raise minus x minus divided by minus 1, that will be minus e raise minus x, because e raise of anything will be that thing only. But then we have to differentiate then negative x. Negative x differentiation will give you negative 1, and that has to be divided. So e raise minus x divided by minus 1 will be minus e raise x, minus e raise minus x. X square will be 2x, so 2x e raise minus x, negative minus x. So minus 2 we are taking common. X e raise minus x will come. Now again we have already done a question in the previous 2 questions we have seen. So you have to again apply the same formula here. So let's do the first part here. E raise minus x will be negative e raise minus x, so negative e raise minus x will be there. Minus 2 I am writing it here, and this whole has to be integrated again. We will integrate this separately and then we'll put it in the rear part after 2. So x, first function, integration of e raise minus x, then integration of differentiation of the first function, that is d by dx of x, that will be 1, and integration of e raise minus x will be negative e raise minus x, so negative you can take outside. So this will be x e raise minus x, and negative e raise minus x, negative will come, minus x e raise minus x. This will be negative, it will come out, e raise minus x. Now what all we got? There is a negative, you can take this negative outside, and there is a negative 2 already, so negative will become positive. Let me write this first. Negative x e raise minus x minus e raise minus x, that has to be written. Then negative has to be taken outside, and that will make this negative 2 as positive 2. So let me write the final answer here. Let's take negative e raise minus x outside. That will make it our life more easier. If you take negative e raise minus x outside, it will be x square inside. When you take this minus e minus x and this minus e, all will become positive. So it will be positive 2x, because already negative was taken outside, plus 2x plus 2 plus constant of integration, and that will be your final result. Please remember, there will be 2 times we have to apply the same formula. Okay, first Then again we got this negative 2x e raised minus x. That was again the formula was applied. So this is how you're going to go about it. There are various questions with e raised x, e raised minus x which are coming up, and I hope you have a better idea now. This question will be taken in the next discussion. Till then, thank you so much and have a good one.